Hello everyone. Mostly in the industry, we are working on various systems like PLC, HMI, VFD, and communication type field instruments. And worried about their communication. Because every system brand offers various communication methods. So, in this video, we are looking at communication between PLC and VFD drive. We are connecting the Allen Bradley MICROLOGIX 1400 series on the PLC side and the Siemens SINAMICS V20 series on the VFD drive side. Let's get into the video. Okay. Let's first look at SINAMICS V20 VFD side. SINAMICS V20 VFD supports the USS Modbus protocol. At pins 6 and 7, you get Modbus port P plus and N, respectively. Also, at MICROLOGIX 1400 PLC side, the Modbus port is available on channel 0. Let's configure Modbus communication on both sides. First, we have to configure some parameters on SINAMICS V20 VFD. For Modbus communication, we have to assign connection macro CN011. This is a shortcut parameter assignment for Modbus communication. Or we can manually assign Modbus communication parameters. For this, we need these parameters. Let's configure them one by one. For all parameter access, we need to set parameter P03 to extended mode. So, we can access now more parameter settings. In Modbus communication, first important parameter is P700. This parameter is used for the selection of the command source. This parameter helps us to start and stop a drive through the Modbus command. After second most important parameter is P1000. This parameter is used for the selection of the frequency setpoint. This parameter helps us to assign VFD frequency from Modbus. Then set a parameter P2010. This parameter is used for assigning a USS or Modbus baud rate. Currently, we assign a 9600 bps baud rate for communication. Then set a parameter P2014. This parameter is used for assigning a USS or Modbus telegram off-time settings. Here we set 0 for the telegram off-time parameter. Then set a parameter P2021. This parameter is used for assigning a Modbus address. For current communications, we set 1 for SINAMICS V20. Parameter P2022 is used for Modbus reply timeout settings. This parameter is used to set a Modbus response time between a master and a VFD. Next parameter P2023 is used for RS-485 protocol selection. Currently, we used Modbus protocol communication. Let's see now MICROLOGIX 1400 PLC side. First, create a configuration between MICROLOGIX 1400 and RS links. Here we already configured a PLC in RS links. For more details on configuration settings, please visit our channel. Here you can find a detailed video on MICROLOGIX 1400 PLC hardware configuration. Before starting the next question, I have requested the Autonetics viewers. If you love our videos and channel, then please like this video. This is more motivation for us to make a new video and share more knowledge with you. That would also help others to more easily find our videos on YouTube. Be sure to subscribe and hit the bell icon, so you can receive new video notifications quickly and never miss the knowledge. Now see the RS-Logix 500 configuration settings. In the controller property here we set MICROLOGIX 1400 controller. After that, set the channel configuration property. Here we set a property for channel 0. First, set a driver for communication. That is Modbus RTU master. Set a baud rate of 9600. Then set parity is even. The stop bit is 1 and the data bit is 8. In the protocol control section, we set no handshaking for the 485 networks. Then apply overall settings and check the channel status. Here you can see the data of send-receive for channel 0. Now let's see the programming. Here we already design a program. We create an interruption for message instruction. And created a 1 millisecond bit for the motor control command, reference frequency command and data read command. Motor control for SINAMICS V20 required control commands like 1151 for forward. $31.99 for reverse, $11.50 for motor stop, and $12.78 for VFD fault reset. And all these control commands move into the data register N7:1. For control commands calculation, refer to this table. For forward run, we can calculate the 1151 value accordingly. Calculate the same $31.99 value for reverse run. 1150 for stop command. And 1278 for VFD reset. Now looking into how the control command works. Here we assign a message instruction for the control command. This message instruction helps for data read-write purposes. Here we already created an MG9 data block for message instruction. For the control command declaration, we assign a write single register command for Modbus command. We assign an N7:0 in the data table addresses location. Here we already moved all command data. Declare 16-bit data size is 1 in size and element. Declare message instruction timeout period is 2. Here declared Modbus address for SINAMICS V20 is 1. So, put the same address in slave Modbus address. You can find the Modbus address in the SINAMICS V20 user manual. You can see in a table for the STW control command inverter register address is 99 and the Modbus address is 40,100. This STW command control this parameter. So, using 40,100 you can access the whole command. So, assign the Modbus address as 40,100 in the massage instruction. And 100 data addresses were found in MB. Then close this message instruction command. Here we complete the control command settings. Now let's see the drive frequency command. Here we provide a frequency to N7:50. And move it into N7:2. For the frequency command message instruction set setting same as we do for the previous block. Here set the Modbus command is to write a single register. Now for this time data table address is N7:2. Set data length is 16 and the size in element is 1. Because here we write single 16-bit register data. Put message timeout delay is 2. And the slave node address is 1. Now let's check the Modbus addressing table once. Here you can see the HSW register on the inverter address is 100 and the Modbus address is 101. Using this HSW you can access this register which is a frequency reference. So set 40101 in the Modbus address location and set the MB data address as 101. Then close the message instruction setting window. Here in N7:50, we assign 8000. Then you can have approximately 24 Hz frequency. If we change here to 10,000 then you get a 30.52 Hz frequency. Then here we change the N7:50 value to 16,384 then you get a 50 Hz frequency. Now let's see the control commands. Here we now turn on the forward run command, which is 1151. Here you can see the motor start rotating in the forward direction. Now see how we read data from the VFD drive. Same message instruction we used for reading data from VFD. For read purposes, you need to change the Modbus command is read holding registers. All read data is now stored in N7:3. Set message timeout delay as 2 and slave node address as 1. Now let's see what data we collect from VFD. You can see through this table. Suppose we want to read data of output frequency, output RPM, and output current, then need to read these Modbus addresses. So that's why we select read Modbus addresses as 40024 and assign the size of element of read data as 3. Now you can see actual output frequency, output RPM, and output current respectively in N7:3, 4 and 5. For more details or information, please look at the description link. Thank you.